Hi, my name is Xinlei, and today I'll be presenting Aware, intuitive device activation using Prosody for natural voice interactions. And this research was jointly conducted with Zixiong and Rekimoto, and it was done when I was a researcher at the University of Tokyo, and now I'm a researcher at Huawei. So voice interactive devices are becoming more and more popular, and there are voice assistants, smart speakers, and even edge computing devices. And to use such device, the first thing we need to do is to call its name, and such method using keyword to activate the device is called KWS, or keyword spotting. However, although this is the de facto approach, it has many problems for misactivation, such as it may respond to keywords that are not intended for device activation. And also, other researchers find that it can also respond to totally irrelevant keywords, such as unacceptable may also activate Alexa. And this kind of misactivation can happen rather frequently, so it's a serious problem. And there are also previous other work that trying to help with this situation, such as proposing gaze-based approach for device activation. However, because they are using cameras, they can raise other privacy concerns. And also for voice-only approach, someone proposed to use customizable keywords, but still it's using KWS. And also some others propose to start the speech with feeder and higher pitch, but it can be very unnatural. So for us human, actually we can identify when people are calling our names, if they're actually calling us or just mentioning us. And also in this kind of daily conversations. Do you know Yang?
No, please say.
Oh, he is a new guy in your office. I think you should talk to him.
Great.
Oh, there he is. Hey, Liang. Liang wanted to meet Alex.
Hi. Hi, nice to meet you. Nice to meet you too.
So in this case, although the keyword Liang appeared 3 times, when they are spoken in different intentions, their prosody is kind of different. And also there are other researchers showing the similar results for this. So based on those facts, we wonder if there are some patterns in prosody that can be used to differentiate calling voice and the otherwise not calling voice. And if there are, then maybe we can use that to develop much more intuitive and secure device activation method, and such is the motivation for this work. So we set off to collect some voice data to explore possible features to describe this. We recruited 11 participants and asked them to talk to the device and sometimes talk to people by following a script with different keywords, and also we asked them to speak in different directions and distances to the device to investigate the effects of those factors. And after extract the keywords and did some analysis, we find some interesting results. So for pitch variations, we find that calling voice are much more varied than the not calling ones, in that the calling ones has a small rise in the first and then drastic drops in the middle, whereas the not calling ones are much more flattened. And also, calling keywords tend to be much more longer compared to not calling ones. When we look at the voice quality, we find that the calling voice tend to be much more clear than the not calling ones, and they are louder. Also, to investigate the effects of the distances and different directions to the features we're using, we ran a linear discriminant analysis and find that our features are robust to different distances and directions. So based on these results, we built a classification model based on CNN and then ran a series of tests across different keywords, distances, and directions, and find it still stable. And based on this classifier, we built a prototype smart speaker that only responds when people are speaking in a certain prosody. And here is a demonstration for this. Do you know the device called Alexa? You can call Alexa and ask questions. But those are not calling voice. Alexa, what is the weather? This is calling.
Right now in Bankyoku, it's 34 degrees Celsius with mostly sunny skies.
Alexa, to single words with different prosody.
Hi, how may I help you?
Alexa. It's different keywords. Assistant.
Hi,
Computer.
Hi, how may I help you?
Computer. And without visualization, so it's faster.
Assistant.
And this also worked with unseen
Hi,
user
how may I help
and
you?
with different keywords.
Assistant.
So we also conducted a user study to compare Aware's response accuracy and usability to Amazon Echo. Specifically for Aware, we compare the model's accuracy with completely unseen voice, and also with the trained prosody patterns that are closer to what we find in the data collection experiment. And as for the results, we find that Aware has a better response accuracy compared to Amazon Echo. Especially if you look closer to the data, we find that Amazon Echo is responding too many times to not calling voice, so it's causing its recall rate for not calling voice to be very low. And such is the problem we are raising at the first place, and it's actually happening. And also for usability, we ask participants' subjective opinion over how does the device responded, if it is to their expectation, or if it's easy to use or easy to learn for using Prosody to activate the device, and if it is intuitive, natural to use, and people think that yes, it is. Because we also tested Aware's performance with untrained words, we find actually an unseen calling prosody in our experiment, in that people actually are talking in a much shorter duration when speaking the keyword compared to what we find from our data collection experiment. So we used those samples actually to retrain the model, and actually in this time, the accuracy improved much better than the initial results. So this problem can be solved simply by collecting more data. Even more interesting, because our model is giving a rather good performance across different keywords, we want to investigate if our model is also work with completely unseen keywords. So we pick up 4 words, 2 in English, 2 in another language, and to see if it can pick up calling voice and not calling ones correctly in random order, and it's actually working pretty good. So here's a short demo of this. Do you know the device called Zhang? You can call Zhang and ask questions. It's not responding. Zhang, what is the weather? Calling voice.
Right now in Bakyoku, it's
Okay. So although this is an early result, but we think this result indicates that prosody-based activation may work independently from specific words, and this direction totally worth more exploration. For more details, please see our paper. Thank you.